All right, let's do this. So we're gonna talk about circuits, and these are like basic circuits. Okay, I'm not gonna get into depth on anything. I'm not even gonna explain how to get the actual formulas, like how we got to them. Okay, so we're gonna do AC circuits, or pardon, DC circuits, direct current circuits, and they're gonna be resisted. Direct current resisted only circuits. Because I mean, there's a bunch of different things that you can put in a circuit. You can put you got the voltage source, which is you can do it differently. Do it like this, where the longer line is the positive and the shorter one's the negative. You have resistance, which is this squiggly thing, and it's measured in ohms. The voltage is measured in volts. And the other thing we're going to talk about is current, which is what goes, the flow of electrons that goes through the circuit. So you got V for voltage, which is measured in volts. You got R for resistance, which is measured in ohms, the Greek letter. And you got I for current, which is measured in amperes, which is A. Okay, so those are the basic things that we're going to talk about. And they're all related to each other through Ohm's law. Check it out. Ohm's law. Ohm's law says that voltage is equal to current times the resistance. Okay. So from this equation, you can get you can solve for any other, variable. So current equals the voltage over resistance. Resistance equals voltage over current. And yeah, that's basically the most important thing in these EV circuits. Okay. Ohm's law is overpowered. Okay, it's OP. So now let's talk about, well, I guess the other thing that goes through a circuit is power, which is current times voltage, and it's measured in watts. There you go. And there's a bunch of different formulas. Like if you substitute Ohm's law into this, you can get a bunch of different formulas. Like if you substitute IR for V, you got I times IR, which is I squared R. If you substitute I, you got V over R, so you got V squared over R. A bunch of different formulas for power. Um, you don't have to learn all of them. You just know the basic Ohm's law and the basic one, and you can derive the rest. Okay, so a circuit can either be in series or in parallel. Let's see, in series, what distinguishes them is how many ways can the current go? Like how many different directions can the current go? So in series, there's a circuit in series. Let's do another resistance. Okay. There's a circuit in series because the current can only go this way. There's no other path that it can go through. So that's how you distinguish if it's R1, if it's in series or in circuit or in parallel. If it's in parallel, let's see, parallel. If it's in parallel. This is something in parallel. Um, Voltage here. Let's see, let's put a resistance in. Okay, this isn't parallel because the current, once it reaches here, it's called a node. This point here is called a node. Once it reaches here, it can go different directions. Like it can keep going straight, or it can go down, you know. And if it keeps going here, you'll notice once it reaches this point, they meet up again. The two different currents that split up, they meet up again here, and it goes back to the start. You see. So what happens here is that it split up into two different currents, I1 and I2. Well, I guess this would be I1, and so this would be I2 and I3. And if you just just logically, you see that I2 goes through here and then stops here. I3 goes here and then stops here as well. So what does that mean? That means, and it forms again I1. You see, it becomes I1 again. So what does that mean? Just logically, that means that I1 is the sum of I2 and I3 because I2 and I3 came from I1 splitting up. And I1 is formed again once I2 and I3 come back together. You see what that means? You see what I'm saying? So what's the difference between these two types of series? Well, a series and circuit, the main difference, there's a couple things. First, if it's in series, the current I is constant. So that means that I total equals I1 and equals I2 and it equals I n. Also, voltage does drop. There's different voltages in each resistance. Each so in each resistance you can calculate a different voltage. You remember Ohm's law? V equals IR. So V1, the voltage in this first resistance equals I times the resistance 1. And V2 equals I times the resistance 2. And V total equals I times the total resistance or the equivalent resistance. Okay. So what I'm saying is that there are voltage drops in series circuits. It's not constant. There are voltage drops. So in parallel, it's the opposite. V is constant. V is the same in each resistance that is in parallel. Okay, so voltage 1, voltage in resistance 1 is equal to the voltage in resistance 2. Oh, voltage in resistance 2. Which in this case is equal to the voltage, the total voltage as well. And current is not constant because what we explained earlier, it goes different directions. So it splits up and, it's not constant. Okay, so I talked about equivalent resistance here. How do we find equivalent resistance? In a series circuit, the equivalent resistance is the sum, just literally just a straight up sum of all the resistances that are in series. So in this case, the equivalent resistance is R1 plus R2 because they're in series. Very simple. Very simple. Now, this might look weird, dude. This might look weird. But the equivalent resistance in a parallel circuit is the reciprocal of the sum of reciprocals. Okay, that's how I remember it. It's the reciprocal of the sum of reciprocals. So it's 1 over 1 over R1 plus 1 over R2 plus 1 over whatever, however many parallel resistances there are in that section of the circuit. So yeah, and yeah, dude, that's really all you need. There's all the theory. Okay, I think I'm gonna cut the video here. This is gonna be a theory video, and then we're gonna do some practice. But yeah, man, there's really you see how it's not a lot. It's all like Ohm's law and identifying when it's in series and when it's in parallel. Okay.